If you try to count all the positive factors of 360, you will almost certainly miss one and then get an incorrect answer. Of course, it would work. It would work perfectly if you were listing like 1 and 360, 2 and 180, 3. But the trouble is, 360 has so many factors. And literally, the reason that there's 360 degrees in a circle is like the Babylonians chose that number because it was divisible by so many other numbers. So if we don't want to make a mistake, we don't want to spend hours of our life just counting positive factors of 360. What's going to be the quick way to solve this? Well, what we can start by doing is finding the prime factorization of 360. So we can break this down to parts. We can do a factor tree, or we can just kind of write it down by 360. Well, that's 36 times 10. 36 is 4 times 9. 10 is 2 times 5. 4 is 2 squared times the other 2 is 2 cubed. Plus 3 squared times 5. When we have these counting questions where it's asking how many of something, often you can use counting techniques to do this. Those core techniques are called combinations and permutations, but we don't need to dive too deep into that here. All that we need to know is that when we're counting these positive factors, we could have 0 2s, 0 3s, and 0 5s, in which case the positive factor is just raising all of these to the power of 0, which is just 1. You get 1 times 1 times 1. Or we could have 1 2 and then 3 to the power of 0, 5 to the power of 0. Or we could have 2 2s or 3 2s. We could list out all of these possibilities in terms of, okay, well, which of the prime factors could we have to get all of the total number of positive factors? Now, we're still going to be listing out a lot of things here. So again, is there a quicker way to solve this? Knowing that we can have 0 for each of our powers, or we could have up to the highest power on each of the primes. So here we could have 0, 1, 2, or 3. There's 4 options in terms of the number of 2s that we could have as factors of the 360. We could have 3 to the power of 0, 3 to the power of 1, or 3 to the power of 2. There's 3 possible options here. And we could have 5 to the power of 0 or 5 to the power of 1. There's 2 possible options here. So the total number of positive factors of 360 is just 4 times 3 times 2, which is 24. Much quicker than listing them all out. Would be possible, wouldn't necessarily be fun. This is a quick method to calculate the number of positive factors of any number. We just have to find the prime factorization, add 1 to each of the powers, because that tells us the number of options we have for each of those prime factors, and then we multiply them together. And that gives us the total number of positive factors of any number. So if that's a useful technique that you want to remember, drop this a save and send this to a friend who you think would like it as well.